Hey guys, so let us see what this silly question means. So the question name says minimum ASCII delete sum for two strings. Right? We are basically given two strings. We need to return the lowest ASCII sum of deleted characters to make the sums make these two strings equal. Right? We have this C and it, and if we remove S from here and T from here, then we will get EA. So we need to sum up the ASCII value of S and T. Okay, so which is basically equal to 115 and 116. Similarly, this case, let's just see this in whiteboard, right? So we have this S1 is delete. Let's just read, yeah, and the S2 is basically delete. Okay, so if you can see, in order to make both the strings equal, we can't delete this D because it's not present here. We can delete this L and then we can delete this E. Okay, so what remains? It remains E, E, and T, and similarly here also it remains E, E, and T, right? We are deleting D, L, and E. Let's verify. If you can see, we have deleted D double E from the delete D double. Okay, one second. Is deleting D double E from delete to turn it into LET. Okay, so what it basically means is we can achieve this, but the fact is deleting D and E will cost us some ASCII value X, suppose. Okay. So we need to find the lowest ASCII sum, right? We need to find the lowest ASCII sum. So how this can be done? By the question, it tells that if we delete D double E, then it will give us LET. Okay. Then we can delete this E to get a LET. So removing this E and DEE will cost this much of ASCII. Okay. So the question says that between these two, the lower one should be output. Okay. I think that's clear. So let's see how we can achieve the answer. Okay. So we have delete. We have delete. Okay. We can see clearly. We already know the longest common subsequence of a particular problem, right? We already know that. So when we know the longest common subsequence, we can definitely make use of that, because at the very end, we are only having a common subsequence, right? Now, listen to me carefully. Okay, we need to find minimum ASCII deletion. So that means if we have a string A, B, C, D, E, F, if suppose we are deleting these things, okay, in order to have this minimum, we need to have other ones maximum, right? This thing should be max. That's obvious, right? Because overall the string is same. So my statement is that in order to make both of them equal, rather having to see that the minimum ASCII should be, the ASCII deletion should be lowest, we should focus on the longest common subsequence should be high. This value should be high. How this helps us is this L double E. If we can see the ASCII value of this L double E is the highest among all the values, because the other one that we see just few minutes ago is we can achieve double ET, right? But double ET's ASCII value somehow lower than LET, L LET, right? Because by deleting D E and E E and E, we are finally getting LET. You can just assume this like E E T and LET. This E is common. You can just see that this T is same. L is higher, right? L is higher than E. So definitely this is strictly greater than. So as we know this now, let's focus on how we can have the longest common subsequence by taking account of ASCII value. So let's see with a dry run, right? We can have delete, we can have lead. First, we are at the first. Let's start from the end. So we are at the same point. Now these 2 points were not equal, right? So either we can move this one further or we can move this one further, right? This is the basic LCS we already know. Okay, so suppose we moving this one. Okay, then we have the option of, now what we have is we have this one, we have this one. Both of them are same. We already get, so basic LCS what we got, 1 plus move is j minus 1 I minus 1, right? But instead of this one, now we can have the ASCII value of this, right? So what is the ASCII value of this? If we simply add the integer value of this s of I, then that will be the ASCII value, right? So we will add up E. Then we move forward in both the cases. We saw that we don't get an answer. Uh, uh, uh. Yeah, we saw that we have T, we have E. Now we can move this forward. Okay. Now this E and E are equal, right? So we again add up this E, move forward, end up having it here. Now we also get this. We are moving forward. As this string is now empty, so we got a ASCII value of this. So this one is particular LCS, but this is not the maximum one. We need to find the maximum one, right? Definitely need to find a maximum. So this particular thing that we encounter, we first shift this one, right? So we first shift this one. So this is not actually correct. This is not actually correct. So we can get it from the recursion, and finally we can have a maximum also, right? If suppose here we move this one first, if we don't move this one, let's see how the optimal answer is getting generated, right? Let's just see that. Okay, now we are at this point, right? Now as this both s of I and p of j, these are not equal, right? So we will move this one. In the last case, we are moving this one, this thing. Now we are moving this thing to this iterate. Okay. Now, as you can see now, T and T are equal. We will add up T in our LCS value. Okay. Then we will move both of them. Now we are at E. You can see this is also equal. We'll add up, move forward. Now we can see that we have L, we have E here. Both of them are not equal. So either we can move this one further or we can move this one further. Right? Let's suppose we are moving this. So we are at this. Now we have same L in both the hands. Moving this, moving this. Now as this string is empty, we'll basically loop out from the LCS. And this is our final P, E, and L. As you can see that this is the answer. This is particularly our answer. This one, LET. Right? I hope this is clear. Now, as we are now finally giving that the maximum common subsequence LCS. Suppose this value we return at as LCS. Now we need to give the deletion value, right? So suppose this is the string and this particular values, this is the second string and this particular values. So suppose this red things, this red things are common. This is the P, E, and L. Then we need to tell in answer that what are the remaining things, right? What are the remaining things that we need to output? So how we can get the blue one? Basically, we add up the total of total ASCII of this one. We'll add up total ASCII of this one, and then finally we'll remove this, which is basically LCS. We'll remove this red. This gives us the total of both strings minus 2 into the LCS that we already calculated, right? So this is particularly an answer. So what is the time complexity? It's basically exponential, right? But as you know that for the LCS we can have dp, and time complexity becomes of n square basically. N square is basically for n into m, where n is the s size and m is the t size, right? Yeah, that's the basically the time complexity. And space complexity will be dp of n into m, because we'll be storing this, right? Let's just code it up. Yeah. So basically let's first have the tot. This is the total. Oh, okay. So we will first add the ASCII of the first string, then we add the ASCII for the second string. Now what our formula says is to return total minus 2 into what our LCS function does. Okay, so now this LCS is basically the LCS that we generally know, but with an ASCII modification. Let's just see. We are having the private, then we will have the LCS function. Okay, so string s1, string s2, int n m. If suppose any of them is is 0, then we simply return a 0. And if suppose s1 of n minus 1 is equal to s2 of n minus 1, that means we should basically add up this value, right? This ASCII value, and then we'll again call the LCS function. That's what we know, right? We move forward with both of the pointers. Finally, return this. Let's just store it in an answer. If this is not the case, then the answer would be max of. We either move the left pointer or the right pointer. Right. And finally, we will return the answer. Let's see it work. Yeah. But now it's exponential time complexity. In order to make it n square, we need to introduce dp here, right? So let's have a dp vector of dp. We'll check if dp of n minus 1 minus 1 is equal to minus 1, then we'll definitely return whatever the value present here. And also we should store this n minus 1 is minus 1, and we should also initialize dp with sign whatever the value vector of int minus 1, right? This should pass. Okay, int n equal to s1 dot size, n equal to s2 dot size. You can just this seems to be fine to me. Let's just solve this. Okay, now it's saying memory limit exceeded. How this is going memory limit exceeded? Find out the root cause. So 80 out of 93 test cases were passed. Okay. Now for this test case, we should get we need to find out what is the particular error we are getting. Mm, so this dp is basically having this much size, is basically same. I think we should pass it by reference, because the reference, it will make a copy on each call, right? Yeah, that's the case. Yeah, yeah, this is how you, you should debug, right? I also did debug just now. So this is how you should debug and solve particular question. Thanks.